Bad thoughts usually come to mind when you think of the word radiation, but solar radiation is actually a very beneficial thing. It's sunlight. Every living thing on Earth depends on sunlight for survival. It warms the planet, provides food for plants, and in general just makes us feel pretty darn good. I don't know about you, but being outside on a sunny day, soaking up all that energy, is a really nice feeling. Solar radiation is all of the light and energy that comes from the sun, and there are many different forms. The electromagnetic spectrum explains the different types of light waves that are emitted from the sun. Light waves are similar to waves you see on the ocean. They move up and down and travel from one place to another. The difference is that instead of the water vibrating up and down, light waves are vibrations of electromagnetic fields, hence the name the electromagnetic spectrum. You can think of the spectrum like a piano keyboard. One end of the keyboard has low notes while the other has high notes. The same is true for the electromagnetic spectrum. One end has low frequencies, the other high frequencies. Low frequency waves are low energy waves with a long wavelength. The length of the wave itself is very long for a given period of time. These are things like radar, TV, and radio waves. High frequency waves are high energy waves with a short wavelength. This means that the length of the wave itself is very short for a given period of time. These are things like gamma rays, X-rays, and ultraviolet rays. You can think of it like this. Low frequency waves are like going up a hill that slowly rises in elevation, while high frequency waves are like going up a steep hill very quickly. The height of each hill is the same, but the elevation either slopes gently over a longer incline or slopes up quickly over a shorter incline. The frequency of the electromagnetic wave determines how much energy it carries. Electromagnetic waves that have longer wavelengths and therefore lower frequencies carry much less energy than those with shorter wavelengths and higher frequencies. This is why X-rays and ultraviolet radiation can be dangerous. They carry so much energy that if they enter your body, they can damage your cells and cause problems like cancer and deformities in DNA. Things like radio and infrared waves, which carry much less energy, don't really affect us. This is good because you certainly don't want to put yourself at risk just by turning on your car stereo. Visible light, which is the sunlight we and other animals can see with our eyes, falls in almost the middle of the spectrum. We can't see any other waves on the spectrum, which are all just different forms of light, but that doesn't mean they aren't there. In fact, insects see ultraviolet light, but not our visible light. Flowers look very different to them than they do to us, and this helps them know which plants to visit and which ones to stay away from. Solar radiation also affects the overall temperature of each planet in our solar system. Our planet is hospitable partly because it is covered with water, but also because of where it lies in the solar system. Earth receives just enough solar energy, like Goldilocks' bowl of porridge, not too hot and not too cold. The angle of the sun's rays also determines our global weather patterns and seasons. It might help to think of a flashlight pointing at the wall. If you point the flashlight directly at the wall, you get a small area where all of the light is concentrated. Tilt that flashlight either up or down, and the same amount of light spreads out over a larger area on the wall, decreasing the amount of energy that hits one particular spot. On Earth, the sun's rays hit the equator at pretty much a 90-degree angle, which means all of that solar radiation is concentrated in a small area and keeps it warm all year round, like the straight-pointing flashlight. The polar regions, however, get the same amount of solar radiation as the equator, but it's spread out over a larger area because the angle is much less direct, like the tilted flashlight. So the same amount of warmth covers a greater area, making it much colder in these regions. As Earth rotates around the sun each year, it also tilts, so sometimes the sun's rays are more direct in certain places than others. This is what creates our seasons. It's like pointing the flashlight of the sun directly at some parts of Earth during certain times of the year. When the northern hemisphere is tilted toward the sun, receiving more direct solar radiation, it's their summer. At the same time, the southern hemisphere is tilted away from the sun, so it's their winter. The reverse is true during the opposite seasons. During the northern hemisphere's winter, that part of the Earth is tilted away from the sun, and the southern hemisphere is experiencing summer because they are tilted towards the sun, receiving more direct solar radiation. Believe it or not, during the northern hemisphere's winter, Earth is actually closer to the sun than during its summer. So while the distance certainly plays a role, the main factor that influences the temperature is how the sun's rays hit Earth, not how far they travel. All that stuff we call sunlight is actually solar radiation. Like waves on the ocean, light also travels in waves, but light waves are vibrations of electromagnetic fields. Because of this, they're classified along the electromagnetic spectrum, which categorizes different types of light waves, like notes on a piano keyboard. On one end of the spectrum, we find low-frequency waves, such as radio waves, infrared waves, and radar. On the other end, we find high-frequency waves such as gamma rays, X-rays, and ultraviolet light. Solar radiation plays a large role in Earth's climate. We receive just enough sunlight to make Earth a nice place to live, not too hot and not too cold. However, Earth is not warmed evenly, which is why even though the equator and polar regions both receive the same amount of solar radiation, they're different temperatures. The angle of the sun's rays is also what causes Earth to have seasons. As Earth orbits the sun, it's tilted at an angle. This means that throughout the year, the sun's rays hit different parts of Earth more directly than at other times. So even though the northern hemisphere is closer to the sun during its winter, it's still colder because it's tilted away from it.